Hello, everyone. Welcome to this session. I'm Lu Yan. I'm a data scientist from LINE Fukuoka Data Labs team. Today, I will talk about time series data prediction for service ops. Hope this session will be useful for you, especially for those who want to build a similar data prediction tool as us. So first of all, I will introduce our project background and also our project members. Then we will have a look at our time series prediction tool. And at last, we will talk about the recent achievement and also the future prospects. First, let's talk about the project background and the project members. There are 3 people who are working on this project right now. Besides me, Ifan-san and Terry-san are machine learning engineers. They are also helping build the prediction system. First of all, you might ask, why do we start this project? Here's a typical user case I want to share with you. For example, a user buys a new iPhone. He is trying to transfer his LINE account from the old device to the new device, but he met a problem. Then what he will do? Actually, he will contact us via an inquiry form on LINE's website. This inquiry form is just like the screenshot on the right side in the slide. But what is behind this inquiry form? Actually, LINE Fukuoka customer care team is treating those kind of inquiries. But they also have a problem. How many users' inquiries do they need to treat for each LINE service? Every month, every day, and every hour. Why is it important? Because they need to do the workload and resource planning. They need to know how many people do they need to treat those inquiries next month. Do they need more people during the iPhone release period? Do they need to outsource more work? To answer this question, our LINE Fukuoka Data Labs team and the LINE Fukuoka Value Management Center are doing the project inquiry count forecasting. In the previous example, it's only about LINE app, but actually we are also supporting other services like LINE Store, LINE Create Market, etc. For each of those services, actually a separate team is treating those inquiries, which means we need to do a separate prediction for each of those teams. You might already understand the problems here. Actually, there's dozens of prediction required every month for different departments. And the project communication cost is also very high. You may ask why the cost is high here. Just take the previous use case as an example. iPhone new release actually is a big feature impact because just after iPhone release, more people will change their mobile phone, which means more issue might happen when they are doing either the new registration or the account transfer. Thus, the inquiry count might increase as well. Or if there's a new semester, there will be a similar trend. Those kind of information is very necessary for the data prediction here. We need to know all those feature impact. But actually, for different departments, the feature impacts varies a lot. That's the reason we need to communicate with each of those teams. But we have limited number of data scientists. You can see there's a gap here. To solve this gap is also one of our motivation. But luckily, our data are all from the similar web form. So the data structure is quite similar as well. But we still need to do a lot of repetitive operations of data pre-treatment and model training. Then we start to have a new idea here. What if we develop a tool not only for data scientists, but also for non-data scientist users from LINE business and operational service department? For non-data scientists, we want them to do the forecasting by themselves. If it can be done, the gap that I mentioned in the previous slide will be solved. And for data scientists, we hope we automate the repetitive steps which can help us make the work more efficient. So our vision is to let everyone, regardless of their coding level and statistical knowledge, to do relatively accurate predictions with the help of the system. So here's our design. For non-data scientist users, we provide them with a UI, which can help them input the necessary information and do the prediction step by step. And for data scientists, we hope data scientists can use our system with few lines of code, and everything can be done. So let's go into more details about the tool. First, for the overall of this tool, actually there are 4 main components. It's actually the same as the general steps in data prediction pipeline. First, you need to add a project, and then you need to add a data set to this project. You can either add a CSV file or directly connect to a DB. With the data set uploaded, we can train the model with the data set. After the model is trained, we can do the forecast. So this is a very general pipeline of the data prediction. Let's go step by step into details. This is a web form of the project. When we add a project, we ask users to input the necessary information. Here, there's a very different point from other IT projects. We also ask users to enter the Slack channel name. With this Slack channel name, users can receive notifications like this. Why we're doing it? Because model training is very time consuming. We don't want our users to go back to check if the training is finished or not from time to time. So we add this input box as well. After the project is settled down, you can upload your data set. We support different kinds of data sources. You can either upload your CSV file or connect with MySQL DB, and also you can use Presto, Spark SQL, etc. As it is an in-house tool, we also recommend users to connect directly to the internal DB. Here, we also provide users with anomaly detection and imputation function. I think this is very important. Data preprocessing actually takes a lot of time in data scientists' daily work. Someone also says almost 70 or 80%. And it will be rather difficult for non-data scientist users to do it. So we hope user to tick this box and everything can be done for him. With the function of anomaly detection and the missing data detection, their data quality can be improved as well. And on the right side, you can see a circle input box. Here, with this input box, actually you can connect with your DB as well. After data is uploaded, we can start to train our model. We support different kinds of models, such as Prophet, LSTM, ARIMA, etc. We also provide some new models like temporal vision, transformer, etc. Here, which part is most difficult for data scientists? Actually, for me, I think it's the input of the parameters for each of those models. So we provide users with hyperparameter tuning function, so they can directly use this tick, but they can directly tick this box, and then they don't need to input any parameters. Hyperparameter tuning actually is trying to select the best parameters for each of those parameters. And this function will make it possible for non-data scientists to use the models to do the prediction. And we also provide users with model explanation and model evaluation functionalities, which I will explain into more details in the next slides. After the model is trained, users can start to do the forecast. They need to input the necessary information for the forecast as well. And here is a screenshot of the result page. You can see they can download the prediction result file, and also the system is plotting the result for them. So you can see non-data scientists can use our UI to do the data prediction from step to step. But what is the tool for the data scientist? So we provide data scientists with a Python client. Users, the data scientists can use batch jobs as well. And also they can use our advanced functionalities, which I will introduce into details later. Because it is an in-house tool, it's very flexible. Whenever there's a new requirement, we are adding the new features to it. So first example, you can see this is a screenshot of a batch job. Backend, it is Airflow. Data scientists can use this backend to monitoring and can use this tool to monitoring and schedule their jobs easily. Then here is an example of hyperparameter tuner. As I said, it's also difficult for data scientists to do the parameter selection for each of the models. So we also provide users with this kind of functionalities in Python client so they can do the hyperparameter training easily. This is an example when you use Prophet. So normally data scientists will have the plot as the screenshot on the left. But actually we also provide users with decomposition of the formula. So they can have a look at the formula more straightforward and can understand better about the impact from the additive terms and the multiplicative terms. This is a screenshot when you use temporal fission transformer. Actually, with this model, you can see the importance of encode and decode parameters, variables. And on the right side, you can also see the importance of previous timestamps from the temporal self-attention layer. I think this is very useful for data scientists when they do the model explanation. And here's my favorite new feature. We start to support the usage of standard SQL queries to run the model and to do the prediction. So, which means when user writes the SQL code to extract the data, they can also use SQL-like code to run the model, which means it can reduce the steps of doing the prediction. I think it is very efficient for data scientists. And this is a new feature we implemented recently. One of our users asked us to also plot the previous predictions, and this is a screenshot for it. So I've introduced the tools, but what is the system architecture of these tools? Actually, it's very simple. Now I will introduce about the main framework. We're using Django to do the web API. Django is very powerful, so we benefit a lot from this framework. And we are also using Theory to do the distribution of the work. Model training, hyperparameter training are very computational costly. It takes a long time. We don't want them to cause delayed responses, especially when users are uploading data doing the small light tasks. And we also have a log system. We're using Elasticsearch for it. So as you can see, the whole system is simple and easy to maintain. Finally, I will talk about our recent achievements and also the future prospects. At the beginning of the presentation, we've talked about the main two issues we met with in the project of inquiry count forecasting. The first one is a gap between the quantity of prediction tasks and the limited number of data scientists. The second issue is about the repetitive operations of data procurement and model training. Have those problems been solved? I think it is yes. For the first problem, actually non-data scientist users can do the predictions by themselves with our UI developed and the functionalities developed. And now they can ask us for some suggestion about the models and then do the predictions by them on. And we don't need to contact each team and do the prediction for each team. And data scientists are also benefiting from the API developed. So our working efficiency has also been improved, especially when we don't need to consider about the Kubernetes cluster things. We don't need to consider about how to write each of the data visualization, etc., etc. We also received some feedback from the Value Management Center for the project of inquiry count forecasting. After the usage of this tool, their work time has been reduced by 83%. And the accuracy of the prediction is also high and more stable. Before the system is implemented, actually they were using the Excel to do the data prediction. It's a typical manual work. So whenever there's a personnel change, the operations might not be performed as well as before. And also whenever there's a seasonality change, whenever there's a big event, the accuracy isn't as good as now. They are also writing this story in LINE Fukuoka's blog. If you are interested, please take a look. Now, let me introduce our future prospects. We hope this tool can be open to more business departments, and we are also improving the UI of it. As you can see, now it is only a simple web form because we only have machine learning engineer and the data scientist to do this project. Going forward, we are also collaborating with other engineers in LINE Fukuoka, and we hope this tool can be more user-friendly. And we're going to support more types of data visualization. We're developing a library for it. Actually, data visualization is a very big requirement from our users. And they also ask us to add some common features in the model creation page. We already implemented the holiday one, and we are starting to do the weather feature for them. And we are going to support multi-horizon forecast in the future. That's the end of my presentation. Thank you for listening.